Yesterday we talked about, Yesterday we talked about solving exponentials. Today we're going to talk about solving logarithms or logarithm equations. Okay, just like yesterday we had two different types, we're going to have two different types today. Maybe, sorry. What did you say? Because we're going to do it for 2 days, and then we'll be done today. Alright, the first type is if you have a logarithm expression is equal to a logarithm expression. Sorry. I'm going to get this figured out in a minute. Okay, if you have a logarithm expression equal to a logarithm expression, just like if we had an exponential expression equal to an exponential expression, we're going to say that these numbers, the number equals the number. So remember that we have log base b of a number equals e. Well, in this case, we're going to have log base b of a number is equal to log base b of a number, which means that these numbers must be equal. For example, we have log base 4 of 2x plus 8 equals log base 4 of 6x minus 12. Now, the great thing about logarithms as opposed to exponentials is exponentials, remember, we had to get the same base. So the bases could be different. We have to write them in terms of the same number, that kind of thing. For logs, you're not going to have to do that. It's always just going to be log base the same. They're going to match. So all we do from here is say that if these two expressions are going to be equal, then these two numbers must be equal. So 2x plus 8 must be equal to 6x minus 12. This is actually easier than an exponential one. Okay, go ahead, solve for x. What do you get? X equals 5. I don't have any. No, not yet. I don't know. Costs a lot of money. I know.
Oh yeah. Please email us a picture of your cat.
Sure. Okay, extraneous solutions. Okay, these problems can have extraneous solutions, and here's why. The number inside of here, so when you take log of a number, what do we have to know about that number? Here's a hint. What's domain for log? What did you say? Yeah, what is it? 0. Okay, so we have x is greater than 0. So this has to be greater than 0. We can't take the log of a negative number. So we have to check. We plug x back in. On this side we would get 18. On this side we would get 18 also. So that's good. It's actually a solution, not an extraneous solution. What? Yes, it is. Okay, next example. Log base 5 of 2x minus 7 equals log base 5 of 3x minus 9. Okay, if these things are going to be equal, what else do we know has to be equal? 2x minus 7 has to equal 3x minus 9. Go ahead, solve for x. X equals 2. Okay, now we have to check for extraneous solutions. So I'm going to plug in the 2. When I plug it on the left, I get 2 times 2 is 4, minus 7 is negative 3. When I plug it on the right, I get 6 minus 9, which is also negative 3. So it works, right? No, because it can't be negative. It doesn't matter that they're the same. This can't be negative. Log base 5 of negative 3 doesn't exist. Okay, so this would be no solution. Sorry. Because that would be the x equals 2 is an extraneous solution. Some students get confused and they think that if x is equal to a negative, like if this is negative, then that's bad. That's not true. This can be whatever. It's when you plug it back in, does it give you a negative number? Make sense? Perfect. All right, the second type of solving is if you have a log expression equal to a number. Okay, we're going to use our deductive reasoning skills. If we had an exponential expression equal to a number, what did we do? In general. Switch the form. So what might we do if we have a log expression equal to a number? Switch the form. This time we'll be going from Benny to Ben. For example, log base 4 of x equals negative 1. Okay, we have log expression equal to a number, so we're going to switch the form, or swirl if you like that. So we need Ben form. 4 to the negative 1 equals x. So what does that make x? Huh? What? 1/4. Did y'all say 1? I only heard you say 1. So I was a little bit confused. Okay, 1/4. Another example. We have 4 ln of negative x plus 3. Sorry, actually, we didn't check. If we plug in 1/4, is that okay? Yes. Excuse me, thank you. All right. Now, do we have a log expression is equal to a number? No. Can we make it that way? Yes. What do we do first? Subtract 3. So 4 ln of negative x is going to be equal to 18. Then what should we do next? Divide by 4. So ln of negative x equals 18 over 4. And now I have a log expression equals a number. So I need to switch the form. What is the base here? It's e. So I have e to the 18 over 4 equals negative x. To solve for x, I divide by negative 1. And someone tell me what that is. E to the 18 over 4 divided by negative 1. You could. Negative 90.017. Yes. Yeah, second ln. I'm sorry. Okay, if it makes the expression negative. So if we plug it back into the expression here, it's saying negative x, which would make it positive. So it's okay. Yeah, so good point. When you get here, a lot of students want to say, oh, it's extraneous because it's negative, but you need to know, does it make the original expression negative inside of the ln? Are we good? Okay, we're going to try one more. Log base 6 of 3x plus log base 6 of x minus 1 equals 3. Is this type 1 or type 2? you change it to be a log equals a log? Are you sure?
No.
No? You couldn't. Yeah, but then it's going to be 3 plus a log, not just log equals log. You could so easily. No, that was good. I wanted you to think that way. So it's not number 1, it is number 2, I guess, right? If it's not number 1, it has to be number 2, maybe. Can we write this as a log equals a number? How? Combine the 2 logs. Yes. They're both positive, so that means that both of the numbers are going to be in the exponents. So using our condensing properties, we can combine this to be a log, 1 log. This is log base 6 of 3x squared minus 3x equals 3. Now we have log equals numbers, we can switch the form. Are you good? Okay. So we swirl, we have 6 cubed equals 3x squared minus 3x. What is 6 cubed? $216. Okay, now we have a quadratic. How are we going to solve a quadratic? Yeah, we need to subtract 216 definitely first. And then what ways can we choose? Factor or quadratic formula, I think are probably the 2 top choices. Which one do you want to do? Factor. Okay, do any of them have anything in common? The 3, so we can divide out the 3. So it's going to be x squared minus x minus 72. What are the factors of negative 72 that add to give you negative 1? Yep. X minus 9, x plus 8, which is going to make our solutions x equals 9, x equals negative 8. Do they both work? So going back to our very original expression, if you plug in 9, you get positive, positive, so that's good. If you plug in negative 8, you get negative. So this is extraneous. This is the only solution. Right here, right here. Divide by 3. Divide by 3. So this side is just still going to be 0.
How did you go from the log 6 to the exponent?
Change the form. Is this what you're talking about?
Yes.
So this is in Benny form. We need Venn form. So 6 cubed equals this. 6 cubed equals the expression inside. Yes. Huh? No? Questions? Okay, your homework is going to be 25 through 43 odd, and this is still 7.6. Tomorrow we're going to do 7.